we're back from lunch, and it was a longer lunch than I expected. But anyway, long story short, we're going to start in with a new topic. I'm going to break things up a little bit, talk about drawing capabilities and graphics on the device, and then we'll come back to content receivers and content providers and stuff like that. I still have more stuff left on content providers, but it gets a little boring when you're on one subject for too long, and we just covered intents and broadcast receivers right before lunch. And anyway, so if you want, we're going to take a little break from that concept, move on to a different one, and then come back to it. So we'll take a slight detour in our experimentation here. So what we're going to do is look at extending the view using the on-draw method and actually doing some lower level graphics on the device and how that works. And we're going to refer to a custom view in the layout file. We're going to create a custom view, and then we're going to draw some basic shapes on a canvas and use a bitmap image with the canvas as well. So we'll see how the drawing features work. This is a fun project. We're not going to build it on our own. Rather, we'll look at some source code that's already created. If you're interested in where this is coming from, this is coming from the bhacker.com directory. This is one of the tutorials. This is one that's called the not from the supplemental notes, but this one is coming from one of the course materials. Let's go back to here. Here we go. My internet was running a bit slow. It is from down here. It is no, it's not from down here. It is from. Hold on one moment. Go back to here. Okay, now I got to refresh screen at least. I believe the internet is running a little bit slow right now. Tutorials. Wow, it's running a lot slow right now. Draw. Draw 1, draw 2. Are the two we're looking at with the draw lecture solution. And then we're also going to hit multi-threading 1 and 2 with the multi-threading solution. So if you want to go ahead and download these, if you get internet access, that's good. And then I believe events we have looked at already. So we have already done that one. But then we have custom components, and we have a few other things to look at as well. So I'm going to kind of highlight the important stuff. So make sure we get through the important stuff this weekend. So extending the view class, we're going to put a drawing code in an on-draw method. So we're going to assume that the view is placed in a fixed size region, and we're going to create a custom component that's going to be using an on measure to calculate the desired sizes. This is not OpenGL programming. This is drawing. So it's like drawing on a canvas, which is sort of like the draw function of Java extended over into Android. So we can draw some custom shapes and create some custom items here. We have this method here that's called onDraw. Looks like Java actually. In fact, it is Java. This is Java code. So it's the same concept. It's just translated over to the Android platform. So if you're familiar with the canvas, if you're familiar with onDraw, if you've ever done a Hello World in an applet and used an onDraw, and then used a graphics G, and then you created something and you put something out on the graphic, that's what this is doing, but it's for Android. So you can use the same techniques actually. This one here is using an activity, extends view. It's not an activity. It's a particular example here. So the idea here refers to the custom view with a view tag and a layout file. And so we're going to pass the standard attributes to the IED to size the background. So we're not doing the custom component. We did a similar one. So this is going to be an extenuation of an example that you haven't seen yet, because we did the custom controller with a different, I think we did a table or list view controller last time that was working with the same concept of the view. So in terms of our view, looking at the syntax here, it's going to have a view component that's going to have an ID, a layout, a background. This is similar to like the web view, the image view, the scroll view, anything with a view on the end of it follows the same design pattern, and along with the same kind of concepts in terms of the properties that are associated with it. So we usually have a view name in terms of its, and this is what the constructor is doing when we construct a new view, because what we're doing in this project is creating a new view. It's a custom view. So we usually have a view name, and the context is sent to it. So used when you're directly calling the view constructor. usually when you're adding a view to an activity or with your setting a context view. We've all set context views already in the onActivity method, and we set the context view to equal the XML file. So we know that this works with XML interfaces that are converted into r.java components. So then the constructor that constructs the view name sort of looks like this, and the context type is the context for which we're displaying this view, which is why we set the context view, and that gives us our main screen that turns into, you know, activity_main or main XML, depending upon what we're doing. We can also set the view name with an attribute set, so it's used when the view built from a XML file rather than programmatically. And let's not worry about the attributes view set right now, but does come into handy for a lot of different examples. So we have a couple concepts to actually kind of keep in mind here when we're using the onDraw. And the onDraw method is basically just a way of getting stuff out there onto the screen. So the canvas is the onDraw is passed to a canvas, so it's used for the drawing method. So the canvas is our where's our canvas? I don't know. We're drawing on the canvas. I'm not think of it as the window, but the window is a separate component. We have paint, which is the same paint that we get with well, the onDraw and the paint. This is exactly like Java in a it's not Swing, it's not AWT, it's graphic packages that are part of Java. So most of the drawing methods here, draw arc, draw circle, like a paint in the argument. It's different from Swing and AWT where you get paint on the graphics separately from the drawing method. So it's not, it's the foundation that's used for AWT and Swing, if you're familiar with the drawing capabilities of plain old Java. So the paint also incorporates the font size, actually, includes methods for that. So making a point here, point P is equal to new point, and then we can set the set color, set text size of this point P, or point is equal to new point with a point, setting a flag for the type of point we're creating. And then we have common methods for drawing in terms of draw color, draw RGB, draw ARGB, depending upon what attribute we want to set to fill in the region with a color. So note the uses of color, not paint, actually, which is different. It's an API written, it's a class written on top of paint. So it gives us color for Android or color for our different platform. Draw a bitmap, draws a picture, creates a bitmap from a rectangle, or from an image file via the bitmap factory. So we can take and draw bitmaps and then put them into image views of things and draw them on the canvas without having to use built-in components, or without having to use the XML interface either. And then drawing basic shapes. So this is what we're looking at in terms of the example that we're going to see in a few minutes. And then drawing the text actually as well, drawing the path. So drawing images. If we want to draw an image, we we copy in images inside of the resource folder, throw some images into your project, and then draw them on the screen. You can do it through the source code. So if the file is in resource drawable, this directory here in the file is called foo_bar.gif. So you'll need to refer to it as drawable, r.drawable foobar, without the extension. We never mention the file extensions. We can use GIF, PNG, it doesn't really matter what we're doing. We can interchange the file extensions, use combination. They don't all have to be the same either. So often you want different versions of your image file. You're going to load them in the different drawable directories. We've already gone through that yesterday. That was the late part of yesterday, looking at the different. So do we have extra? No, we don't. It's just extra high. We have extra high definition now. So supported image types: GIF, PNG, BMP, and Android Plus only. WebP, because it supports web HTML5, so it supports a lot of newer technologies, which is supported of the 4.0 and above. The earlier ones isn't going to support that image format type. We can also load images into a bitmap by going bitmap pip. Pic is going to be the name of the image variable that we're creating, and then bitmap factory.decode resource, and we're going to decode the resource to put it into a format that's going to be compatible with a bitmap. It's automatic conversion for us, so it works flawlessly normally, so we can definitely use that to populate images throughout the screen. And we can also draw the bitmap, canvas.drawBitmap, where we've got a picture, a left top, a right, a left, a top, a null, so a last large the last argument is the paint, not the opaque image. So in terms of what color we're going to paint it, or the paint component. So triggering a redraw, we can redraw the screen automatically after scrolling. So after the screen is rotated or it's covered and re-exposed, we have the manual way of redrawing it. So manually we can call invalidate on the view. And if called on a thread other than the main thread, it should call post invalidate instead of invalidate. We're going to see this in a few minutes in a source code example. We can go non-manually, automatically on the onDraw directly. So every time the onDraw method is called, the view is repainted for you automatically. So a very simple animation can be done this way by repeatedly doing some sort of thread.sleep, then calling the invalidate. So you can have a picture. In fact, if you're in my, I don't know, there was one class that we did animation. I think it was the iOS class where we put a bitmap up there in an image view. A few minutes, put another one in there. A few minutes, put another one in there. Use it like a flipboard, so you can go through and do some primitive animation. Same kind of concept, actually. So avoid allocating drawing objects in the onDraw because it's going to run too slow. So onDraw is expensive in terms of processing time and speed. You're working with the graphics and the interface. So the onDraw can be called many times over and over again, every time a refresh does. So you don't want to actually put in the assignment of an image to an object type, or you don't want to put in, some heavy-duty calls because, you only have to make them once anyway. And then once you assign them, just have the onDraw do very minimal things. Consequences might be that you don't allocate graphic objects in the onDraw. And it's going to especially true for bitmaps, which applies to paint and other objects as well. You want to be conservative with what you're putting in the onDraw because it's going to run. So here's an example, a view that draws random shapes. So let's take a look at this example so we know what we're looking at. And then we can kind of go forward with this. This one is going to be called apdraw.zip. If you download it, there's 2 PowerPoints that go with it. There's only one final project. And is this the drawing? Let's take a look here. I'm going to zip this guy. It is drawing. Import him into Eclipse. And I believe I still have my, do I still have my VirtualBox running? Well, let me run my VirtualBox real quick so I can load it up. It's worth seeing what we're looking at. At least you can put the pieces together in terms of the capabilities. We're not going to build it, so we don't have to worry about it. But we'll take a look at the code. Oops, what is this? Must have hit the new button on it accidentally. To connect my emulator actually once it gets loaded. I had this running, but I was testing the SMS stuff, and I had a habit of turning it off. Saves memory a little bit with processing as well. So there is, by the way, a way of testing SMS with the VirtualBox emulators, but you have to go through the VirtualBox. You have to set parameters. You can actually test Bluetooth and test USB and stuff through it as well, but you have to go through the settings, and it's pretty hard to configure. I've never actually tried to configure it. Rather, I just trust it on a real device. So let's see. I'm going to run the drawing example so we can see what we're looking at. Wow, we're not looking at much, are we? Forming. Hold on 1 second. Emulator launch. Let's try it again. Might have to run this one. Already running. It might not be compatible because of the project type, which is 4.1.2. So let me change the project type. Yes. No, but the second option is for my built-in Android emulators. These guys here are the built-in AVDs. I know I can select that one, but I want to run it on my other one. So let me show you a little trick, actually. In fact, this brings up a good thing that I discovered earlier when I was showing you the database example. It was loaded for an API that was kind of old. So when I clicked on the database demo to run it for you earlier, and I'll run this one right now to demonstrate what I'm talking about. If you go into Project and go down to Properties, you can change the target. And if you do that, if you open up the demo, actually, let me just do this for you. I'm going to take this out of here. Let me make sure I have it out here first. Let me just do another download of it because I don't have it here. It's worth seeing this actually work. So in here there's a database example right here, database solution. Whoa. I thought I was just going to be able to download it. Well, in there's a database solution. When you load it up, there's a bunch of red marks all over it because, oh, here it goes. We're going to see the red marks soon. The red marks are because of the API was for 1 point something. And this example was written several years ago. And it's like 1 point something or 2 point something. And I don't have the API installed, so it doesn't recognize it. And sometimes you see on the lower part of the screen, you're going to see something that says something like API version something something doesn't exist. You usually see it down here. And if that's the case, you can reset the API level, and you're going to have this problem when you look at some of these legacy examples. And let me show you how to fix the problem. It's worth looking at the fix because you're going to run into the problem. And so while this is still downloading, I'm going to remove the project because I want to fix it again for you. So I'm going to remove this called database demo. I'm going to remove it. I'm going to close the project. I'm going to remove it right out of the, and I'm going to remove it out of the workspace as well. Delete the project. So I don't have it anymore. So that version got fixed. So instead, once this download finishes here, then I'm going to unzip it. I'm going to import it in. I'm going to fix the problem for you so you can kind of see what it is I'm talking about, because this is going to happen over and over again, especially if you're running these legacy examples. And as an example, what I tried to do a few minutes ago to run that other project, it's not going to run on my emulator because my emulator doesn't support 4 point something, and the project's a 4.1 project. So I'm going to downgrade the project. And I can downgrade the project, let me show you that before this goes here, the same way. Although the project's not giving me any problems, it looks pretty good. I see it's set for 4.1.2, and I don't have a 4.1.2 emulator, which is why it comes up blank in that window. Although I do have my VirtualBox running. So if you click on Drawing and you go into the project folder and you click on Properties, see where 4.1.2 is? Click down here. I'm going to come back up here. I'm going to select the 2.3.3. And this may or may not work because if the API support isn't available for 2.3, you know, if I've taken a current project and I've downgraded it back to a lower API, I might end up with a situation in which something is new and it's not backward compatible all the way down, like the feature didn't exist, or making a method call, or using an object that doesn't exist yet in the 2.3, because 2.3 is older than 4.1. I don't see any red marks, so I'm going to be pretty good. And I see my Android version has changed now. So now if I right mouse click and run it and do a run as, I'm going to see it, my emulator, which I'm not going to see it anymore, am I? I should have seen my emulator up here, but I think my emulator is probably going to have issues, so let's just take a look here. Do I not have it? I do have it running. So let me see. I'm going to try something else, actually. I'll try and run another project to see if the emulator just is that, or if that's just that project that's not going to work. Yep, it's working. So my emulator is working. That's another camera example I'm going to show you in a few minutes. But so long story short, this project is not compatible with my 2.3. It's not going to show up in there. So I'm going to run it in the background right now in a 4.1.2 emulator. So I'm going to select this one because I want to see you. I want to have you see the final result. And I have been having some luck, although it's kind of slow. I've been having some luck loading the Android emulators, actually. I call this luck because it's actually loading for the most part. So while this is loading, I'm going to show you the, I'm going to minimize this one here. I'm going to show you this downloaded project here that's happening in the background here. So I've decided I'm going to fix this problem with the database example, so I'm double clicking on it. And shoot, no such file or directory. It's probably not done downloading. Let's take a look here. Unable to expand database. Zip into directory. Desktop. Error 2. No such file or directory. I don't believe the download worked correctly. So let me go back here for a second. See how long this is going to take to download it again. Hopefully it won't take too long. File didn't actually get downloaded correctly for some strange reason. Looks like it's going a little bit faster right now. So maybe this one will work, the one with the 1 next to it. But you should be able to double click on it and download it correctly. So let's take a look here. Maybe this one. There it is. Alright, so now I have it. So what I'm going to do then is bring it in and show you how to upgrade this app. Actually, it's an upgrade for the app because it's in a previous API. So I'm going to go close this, minimize this guy here. Click on File, and I'm going to import it. And this is the same problem I was having this morning, by the way. I just didn't think about the API version. I'm going to go Browse. It's on my desktop. It's in the database directory. I'm going to open it up. This one says database on it. So I'm going to click on Finish. And this one's going to work. Okay, well, it's not the database demo. I'm downloading the wrong one, obviously. It's probably the one called Database Examples. This is the database one. No, this is going to be in the, oh, it's going to be in the, I downloaded the wrong one. It's going to be in the, hold on one second. Let me get the right one. It's going to be in the supplemental notes folder, not the tutorials folder. There's 2 of them. Unfortunately, though, oh, there we go. Seems to be working. Supplemental notes. Let me get the right one. In fact, this one's pretty small. It shouldn't take as long to download either. This one is called Database Demo, and it's not a bad one to go look at, actually. In the meantime, I'm multitasking. In the meantime, this one should be coming up. Oh, it's coming up. This one's going to hold our draw example that we're going to look at the code for in a few minutes. Let's see. Not connected? Not connected. That's good. It's hard to demo something when you can't get to it, isn't it? Alright, well, I'll leave that alone in the background there. While this is going on, we're going to essentially be looking at this example. So this example looks at and uses a bunch of draw components. And so we have the drawing example launcher, which is going to be the main program. That's going to have our onCreate method on here. That's going to use a main XML layout. Let's see if it's working yet. Oh, it's almost there. Problem is that emulator slows my system down. So as soon as it loads, I'm going to close it. This is not going to load, is it? Well, on that demo that I can't bring up, on the database demo, which I probably shouldn't have deleted then, if you go into Project and you go into Properties, you're going to notice that none of them are going to be selected. Well, none of them were selected on my system because I only have, mine starts with 2.2, which is API level 8, and that one was created for API level 3. And you'll see a little red message that shows up on the bottom that says no support for API 3. So just select another API and hit OK, and it fixes the problem for you. So that's how you're going to fix that database problem. So I'm going to take this one out now because we don't need it anymore. Meanwhile, back at the ranch, while this is loading, I guess I'll go back and kill some time with the video, with the example summary. So when this eventually loads, what we're going to look at is we're going to make a view that draws random background circles, rectangles, and bitmaps, and text. And then we're going to take a look at all the sizes and locations and the current dimensions. And what it does is it randomly draws a selected view given a shape that we've defined with dimensions that we've defined using random generation, remember coordinate generations, and puts them out onto the view. And then it redraws it. So we have a redrawing that's triggered by a button. We click the button and it redraws the view for us and gets the ID of the custom view, finds all of the find view by IDs, and invalidates each one of the buttons that when the button is pressed, it invalidates everything. So our random shape view, which extends view, looks like this. So I'll bring up the code for that. I was hoping that was going to load. And, I'm still not loading that one. Okay. So random shape view is the one that we want to be looking at. This is the first example. And random shape view extends view, which is why we're looking at this. And then we have backgrounds, paint, bitmap. So we're going to store a bunch of arrays of information, and then we're going to take the arrays of information, randomly pick an item in it, and combinations, random combinations, put them together and draw them on the canvas. So we're going to create a string that's going to be a message, and the message is going to say Android on it. And we're going to construct, here's the constructor, and the constructor, just like the lecture was telling us, takes on the context. So it's going to programmatically construct the random shapes for us given the definitions that we're going to use. So when we create the object, it's just nothing, it's just going to call super, and it's just going to create the graphic object for us, which is the view. And so this is our random shape view, it's a custom view. So the constructor is going to be called made from the XML file. So what we're looking at is an XML file that's going to be put together that's going to have the random shapes associated with it. If we take a look at the resource directory and the layouts, what we see here then are the rotating draw shapes 1, draw shapes 2, and the skew. If we take a look at what these look like, they're not really going to be showing very much outside of the interface, and here's an example of it, of what it was going to look like when it actually does load up. But these will be in random locations. So it takes the text and the objects that we've stuck out here in the view, and if we take a look at the code for the view, the XML code, here's our view, and our view is nothing more than a rectangular shaped view that's going to be called from our class. Here's our class. So the reason why you're being shown this example is because we're not using a built-in object that is from the library. We're making a component called a view that's going to be our own custom view that is a dialect of random shape view. Random shape view is this class that I've been looking at over here that I've been showing you. Random shape view does this stuff. It creates all of these little shapes, and it uses the word Android in here to randomly stick it. This is just an abstraction of what the class does. It's not going to look like that when you run it. It's going to look different depending upon the random coordinates that are selected for the dimensions and also for the size of each one of the views. So the keyword class is over here. It's not coming from Android : anything. It's not a built-in component, not coming from the SDK. It's a class that we created. This is the class that we created. It's this guy right here, random shape view, that we're using for this. The rest of it's all the same. We have a button on there. The button's going to reset. The button has redraw written on it. It's going to reset the view. And we're just setting the view inside of a linear layout. So the interesting thing is in the old days we used to have a map view here, and it was a Google. We extended a Google API that we included, and we're still doing that actually. We have image views that are running from, and you can create your own specialized image view that does special things perhaps, or has a different shape to it or something. And then what you're doing is, in terms of the class, you're defining the class equals something. And this is the class that you're created right here, given the package, and this is the package that's being used up here. So this is the class here. So we're taking this class and we're putting it in the XML file as a view. And this is the custom view that we're creating. We know it's a custom view because it extends view right up here. So we're creating our own view. We're creating our own object that's appearing on the canvas, long story short. And, oh, We're getting farther. We aren't going to load, are we? Let's see what happens. We might be installing right now. Let's see. I launched it. Has not installed it yet. We'll just give it a few more minutes and see what happens. Once this, I might just leave this emulator up just in case I need to use it again. Oh, look at that. This is back up. Oh, but we're not running. Okay, so I'm not going to be able to use the internet. Okay, we'll just leave that alone. Waiting for this to launch. So it's actually performing a launch on the virtual device. Android 2.3, that's good. Let's give it a few more minutes, so be patient to see if it will actually load the app. So let me talk a little bit more about the random shape while we're waiting for that app to load so we can see what it looks like. It's actually just going to be a view, and the view is going to have these random shapes on it. And it's a view that's created from the random shape view class that we created. And so in here, we're to avoid repeated allocation here, we've got some separate options that we're going to define the paint, we're going to define the bitmap, we're going to define the order system, so we don't have to redraw it over and over again. As I was saying before, we don't want to put the stuff in the redraw method, or the onDraw method, I should say. And we have the random shape view, we have the random shape view. This is going to basically set our view components from the constructor, doing nothing more than calling the onDraw, the super for the random shape view, and the for view, and the super for view for random shape view. So these are our two constructors. And the onDraw method is the interesting part. View colon onDraw method here is going to take and call super onDraw to start out with, and then it's going to take the canvas and then it's going to draw the color of random util.random elements with different backgrounds that we're going to select. So we're going to take a bunch of backgrounds, put them in a structure, and then take those backgrounds. They're going to be basically color coordinates, and then we're going to have a view width, a height, and shape in terms of the you know, is it going to be like a rectangle, is it going to look like a square, depending upon how big the sides are and stuff. And then we're going to have a little loop here that's going to go through and says, for I is equal to 0, I is less than 20, we're going to draw 20 of these suckers. We're going to put some random views, some random shapes out there. We're going to draw a random circle, rectangle, bitmap, and then we're going to put the text out there. So there'll be 20 instances of the word Android on there, 20 circles, 20 rectangles, and then 20 of this bitmap here. That's going to be an image that we're going to use in the project. And then we're going to randomly select a background color. So in here we're going to have a color cyan, color gray, color light gray. Just basically pick some colors, put it into an integer array and called it my backgrounds, and the my backgrounds are actually being loaded up here. And picking a random element. So when you go random element, it picks a random element from an array of elements, and random utility is like random you get in Java. It's used to pick random numbers. It's built-in utility for that. So we're relying upon the random utility. And then on the draw, it's going to randomly change the background color for us. And then when we click the button, it's going to click the onDraw because the button's going to refresh. And on the onDraw is what's going to refresh it for us. It's refreshing it because we're basically selecting a new random number for the background, and then on the onDraw, it's essentially going to be painting the canvas for us. And painting the canvas for us goes back and picks the onDraw for the canvas. So we have the onDraw for the canvas that's going to be essentially being painted again by the random shape view class that's going to be looking at it. And then we have the different sub-components of this for the view, the random circles. So random shape here, looking at the color for the background, and then the random circle, which is going to be drawn on the canvas with a height and a width, and an average shape, which is going to be the a calculation of the two of them. So we have a float X, a float Y, and a radius. We're going to draw a circle with that. And here's how we're drawing the circle. We're going canvas draw circle. This is what I'm talking about when I say it's a low-level draw method. It comes from the same draw method that you get with the regular Java, non-Android. So this code is actually pretty compatible with non-Android applications, which is Java applications. It's using regular old draw packages. And then to make paint, what I'm going to do is set a color, paint it out. So it's going to be a function that's going to be paint. That's going to set up paint given our paint code that we've given it. So. And then we have random rectangles. Same thing, except we're going to do canvas.drawRectangle. And the rectangle is going to be drawn with a left and a top and a right and a bottom and a square color. So we have a color, we have the dimensions. So this is the same method call that you would use as well. Same thing as a circle, but this one's a draw rectangle. And then lo and behold, we have a draw bitmap, which is done the same way. So once we randomly calculate using randomutil.randomFloat, we're getting a random float value for the width, for the height, for the radius, for the picture number, for all of the different components that we're going to use to randomly create these shapes. As generic shapes, actually, but they're not really generic. They're circles and square rectangles and bitmaps. And now we have one that's going to create the bitmap image. So it's called a bitmap factory, actually. Why they called it a factory, I'm not sure, but a bitmap factory is the object. Decode the resource, and we're going to get the resource. Well, what's the resource? It's going to be a file. It's going to decode it, put it into a bitmap format so it can display it on the graphic display for the canvas. And then our random text is pretty much going to do this same thing. We're going to do a text paint or set text size to set the fonts, and then canvas.drawText, and then it's going to be the message that we created, and which is going to be equal to Android, I believe is the name we put on there, and XY coordinate system with a paint. So if you were to write hello world and use non-draw and do it with an applet as an example, this is what the code would actually look like. You just basically do a draw text, and you draw text on a canvas. So it's very similar to drawing on an applet, or drawing on an application, or drawing on anything associated with Java. So here's our helper class. It's our random utils. So we have class randomutil that's making a random R variable. So R is a random type. It's going to be new random. And we have new random int, random index, and different variations, random float, random element. So we're extending out the functionality of random to create these random elements for us. So we can see this random util actually in the package here. Random utils is right here. And so it's I think at this point it's easier to see it from the slide because it's all colorful. And I don't think my example is going to load, but I won't give up on it yet. I'm going to try one more time. Let's see. I'm not having any luck after lunch with the emulators, so let's see. Yeah, let's try it one more time. Got nothing to kill anyway. Nothing to waste. Oh, now it says it's launching. That's good. Yeah, it's going to launch another emulator for me. That's great. It's not going to leave. The first one lost its connectivity for some reason. I believe it may be due to the fact that I don't have internet access, and I think that messes up the ports, the identification, which is an interesting problem. So let's see if this actually does load. It should load eventually, I would say. In fact, that might be the same problem actually that I'm having with my VirtualBox emulator. It might be my lack of internet access that's often causing the issue, or the on and off activity that's associated with it. But we'll give that a few more minutes before I completely give up on it. So the layout file, we saw the layout file a few minutes ago, and here's the thing I wanted to point out. We put the class name in here. And the class name is the type of view that we're creating, because we are creating a custom view. And that class name is a view that doesn't exist. It's one that we've created called random shape view. It's not a built-in view. So now you appreciate when you say image view, map view, web view, all these views. This one, if we wanted to do that, we could add it to the Android API, and then we'd go Android : this, Android : that. But we're not. So the only thing that we're doing essentially is creating a class called random shape view, adding the class in as the class designation for the view. The view has the class equal to this, and then we can set the ID, the layout, essentially for the view component. Because we're working with super, and super is the view, and the view has a layout, has an ID, layout height, layout width, an ID, and those components that go along with it. So here's the example of the activity. We have one that's called Draw Shapes 1 that extends activity, and this one here is just going to open up the view, which is that layout that we have, and draw some random shapes. And then what we're going to do with the button, when the button is clicked, we're going to say the mDraw area, which is the definition of the view area that we're drawing, and we're going to go .invalidate. So invalidate makes it go away and come back. And when it invalidates, it has to be redrawn. And then the redrawn method, onDraw method is triggered, and then the onDraw method is going to paint the view again. And because we're using random numbers, it's going to change it. It's going to paint it into a different location. So the overall main layout looks like this. We've got some buttons on here. That's going to rotate the view, launch a skew, launch a draw shape. And the drawing is going to be an example of it's basically the drawing example launcher is going to be extending activity. So if we go in here, we're going to see a bunch of classes that are defined here. The drawing example launcher is the one that's going to be launching out a bunch of buttons. So if we run this one, which is what is hopefully going to show up here eventually if I don't end up throwing this thing out the window, is that we're going to see a bunch of buttons, and one of the buttons is going to do the random shape view. And then we have the shapes 1 and shapes 2 and all of the other options that are being run from this main interface. And the main interface is just basically giving us a demonstration of some nifty things we can do with the onDraw method in the views. So, let's see. Oops. Alright, so I'm going to leave this one because we've finished sort of the description without being able to see it work yet. Eventually we're going to see it in a few minutes, but that's the first part. So I'm going to move right along to the second part while this is still loading. We'll see how far we can get with this. I'll put it over here actually. So the second part of this just extends the example out a little bit further with some modifications to it. So some of the things that we might be able to do with the canvas, and especially with the drawed items, is to translate, rotate, skew, and scale items in the view. So if we can do that, then we can actually come up with some pretty nifty, and again, this is not OpenGL. If we look at the OpenGL libraries, we can do even more. But that's from even a lower level of abstraction. These are just the built-in Java libraries that are giving us the graphic draw components. So using the shape drawable, the motivation for it, we're going to discuss the making of the shape drawable and the drawing of the shape drawable. I'm not going to go through, this is not a computer graphics class, but however you might probably want to know, we have the XYZ plane. We actually have 3D graphic capabilities, but we need OpenGL to do the 3D. Without the OpenGL, we get the 2D graphic capabilities with the draw package, and the draw package gives us our XY coordinate system, but we still have coordinate transformations that are possible. What does that mean? We can rotate around the Z-axis, we can rotate around the X or Y-axis. The idea here is to, instead of computing new coordinates, move the coordinates around itself using a transformation matrix. So, for example, draw text on a clock face. Don't rotate the position each string, instead translate it to the center, rotate it to the 22 degrees to the left or to the right. And then also, in terms of the Java syntax, what we're looking at is doing a canvas translate, a canvas rotate, a canvas scale, skew, which are built-in methods that are going to work on the canvas to actually create some pretty good graphics. So when this example does come up, let me tell you it's worth looking at. This is why I'm trying so hard to get it to run. It will actually demonstrate all of these interesting things, which you look at this and you go, wow, that's pretty powerful. And all you're really doing is using the canvas and the onDraw method and defining some shapes and adding it to the canvas. So the translate is going to move the drawing from one location to another. Positive X means that the drawing is going to move to the right, negatives to the left. Rotate spins around a center point, so the current center will rotate around that. change translation degrees. Uses Java 2D desktop Java, which uses radians. So this is based on in fact, all of these packages are the 2D Java, desktop Java, the standard version. Just say core Java. This scale is stretches it evenly. The skew moves it, so it's called a shear. Moves it from as points get farther from the origin. And then concatenate, set the matrix, save, restore. All the functionalities are available. So for rotating text, it's actually kind of cool because then your app opens up and you can have a fancy little, I don't know, piece of text that moves around on the screen, rotates, does something interesting when the user clicks on it. You can actually do this for a lot of game programming as well. It comes in handy for different types of animations and graphics that you want to do for games. So eventually what will end up happening is you'll find a need, definitely will find a need for it. I might just have to load this on my device. So, alright, I believe I had it working on my VirtualBox emulator. The only problem is it's stuck in this example is stuck in virtual mode, and I can't get my emulator to go in virtual mode, so this is going to come up virtually if it ever does load up. But what I can also do is stop the video, load it up during our next break, which is the memory issue that's going on right now. May also do the internet connectivity, but we'll see about that. Okay, so make the view, so the idea here is to make the view for the rotation. So I'm going to talk about, just briefly, it gets kind of boring without being able to see the example, so I'm just going to briefly run through this. In terms of rotating the text, the idea is to translate it, so use translate, which is the method. So what I'm talking about is the implementation of these methods on the canvas. So the canvas is going to translate, rotate, skew, and resize, and do things that are going to be appropriate for the particular graphic effect that we want. We can also use uses a fixed size font. We can also change the fonts if we want, so you can guess about the type fonts that it's going to fit. We can change the font size to fit the window. We can let the XML specify the font size as well. And then we can use what's called an on measure to compute the desired sizes so that the view doesn't have to be a fixed size region. It can use a wrap content instead of a wrap match parent kind of component. Because here's what you get with graphics, and this is where we want to use the on measure method. On the device, we have big screens, we have little screens. So if we use one size for everything, how is it going to automatically resize? So the on measure measures the target that's receiving the input, which is going to be the graphic display that's on the device that the app is running on, and then it's going to go through and resize itself to match the dimensions that are there. So on a measure, which means on a capture of the screen information, size and dimensions, it's going to resize itself. So it would be interesting to see actually both of these running, because then we can see, looks like it's going to run actually. And then we could possibly see the on measure work. Installing, I think I've got some success. All I had to do is third time's a charm, or fourth time's a charm. Installing drawing.apk. We're good. I'll give this a few minutes. Let's see if it actually works. See, now I know the frustration you guys go through when you're looking at launch canceled. Failed to install it on the device. 5556, because something was null. I'm not sure what was null. Alright, so what I'm going to do then is kill this sucker. I'm going to do that actually. Excellent idea. So for those of you who I want to see this work. So for those of you who are interested, what we're going to do now is I'm going to copy it onto my Samsung device, because I can't get it to work on either one of these emulators right now. So if I'm going to go into the resource directory, and you guys sitting in front can probably see this, and oh, it didn't get created. I'm sorry, it's in the bin directory. You are right. I'm clicking on the wrong directory here. There it is. So I'm going to copy it onto my device. And sometimes you can see it from a distance. You're not going to have to look at very much here, because there's only a couple of buttons, and when you see the buttons you can actually demonstrate it. And if you have a device itself, you can load it on the device and see it work actually. So what this demonstration is going to do is going to demonstrate the graphic packages for you. And in the graphic packages, let me put this over here. to the device. See, this is much faster than actually running it through one of those emulators. So now I'm going to disconnect it here, and then install it from the SD card. I'm sorry? It's okay, it's working. Parse error. Ah, okay, wasn't working. Okay. Got a parse error. The memory is too low on my computer right now, and it's not making the APK file correctly, which is why it's not loading. So here's what I'm going to do. I'm sorry? No, it's on here. The APK file is corrupted. So I'm going to end this. I'm going to end the recording because the recording was